Okay, I think I got that cleaned up just a little bit. There we go, that's a little bit better. And so now let's move on to the next example. First, they're going to sum up the different methods that we use to solve a quadratic equation. The first one was to apply the zero product property. And that is any time you can you can factor your quadratic equation to where you have a factor times a factor equals 0. Such that, like we have right down here on the example, x squared minus x minus 12 equals 0. The left-hand side, x squared minus x minus 12 will factor. Then we set each factor equal to 0. This came from setting x minus 4 equal to 0, adding 4 to both sides. That's how they got that. And then this solution of x equals negative 3 came from when we set x plus 3 equal to 0, subtract 3 from both sides. That's how they got that one. Okay? That's a pretty quick way to do it, and I'm here to tell you that if you can factor something that's pretty simple to factor, that is quicker and more efficient than even using your quadratic formula. Quadratic formula would work and it would yield the same solutions, but it takes longer. So, factor if you possibly can. That's pretty quick. All right, and the second method that we talked about is, well, no. The second method that we talked about was the square root property. If you had an example like where you could say c squared equals negative 6, okay, c squared equals a number, then you can just take the square root of both sides. Let me change colors here. You can take the square root of both sides, and after you simplify, you will solve for c. Now, they also, with this discussion, inserted the completing the square. And then you apply the square root property. That is this example here, the second example in the box. So we subtract 2 from both sides. Then we need to find the magic number. How did they come up with the 9? How'd they know to add 9 there in blue to both sides? Well, remember, you take the coefficient of x, the 6, divide it by 2. That gives you 3. Then you must square it. 3 squared is where they got the 9 that we add to both sides of that equation. Now, the beautiful thing is that the left-hand side factors correctly. So then we can use, or factors really nicely as perfect squares. Then we're ready to use our square root property. So we have x plus 3 equals plus or minus the square root of 7. And then subtract 3 from both sides to solve for x. Here's an example down below of using the quadratic formula. We just saw a couple of examples. But on this one, they said it's a good idea to go ahead and clear out the decimals. And since each of these decimals is to the 10th, the nearest 10th, if you multiply both sides of the equation by 10, which is totally legal, that'll clear out each of those decimals. Multiplying by 10 essentially scooches the decimal place to the right 1 unit. So you see 2x squared plus 5x plus 1 equals 0 is equivalent to our original problem we had. But now we don't have to mess with those decimals. So you see how they put those values into the quadratic formula? And simplify. If you need to pause it and check it out, do that. That'd be great. But this table sums up the different methods we can use to solve a quadratic equation. Now, the quadratic formula works on everything, but as we discussed at the beginning of this, it's not always the most efficient. If I have, for example, I know I'm drawing arrows all over the place, but if I have that example, c squared equals negative 6, I'm totally wanting just to do the square root property, even though c squared plus 0c plus 6 equals 0 is equivalent to c squared equals negative 6. I could use the quadratic formula where a is 1, b I'd be putting in a 0, and c I would be putting in a 6. But you're still going to end up with the same solutions you have right here, but it's going to be a lot longer. So use a little bit of strategy and planning when determining what type of method to use. All right, next we're going to talk about what is meant by this term, the discriminant. Okay? Y'all, the discriminant is nothing more than the radicand of your quadratic formula. The discriminant is the value of b squared minus 4ac. Now, the reason we want to look at that separately at times is because that's what appears under the radical, and that will determine what type of solutions you get. In example 6, we had a negative discriminant. It was negative 36. Let me flip back over there to show you. Okay, and so scroll. The value of the discriminant was negative 36, and what type of solutions did we get? We got a pair of complex conjugate solutions. That's going to happen anytime the b squared minus 4ac, the discriminant, is a negative. Okay? On the next example, our discriminant was a positive 137. And in that case, we got some real numbered solutions. Now, they weren't pretty, but they were real numbers. You can definitely see that down here in the decimal equivalents of these, or approximations, I should say, of those. So, we can also see, I turned to the next slide. I think I put the example before the chart I wanted to talk about, okay? But depending on what type of number we get for the discriminant, b squared minus 4ac, that's going to determine the number and type of solutions that we're going to be getting when we would actually then go through and solve. Okay? Now, another way to write that that the b squared minus 4ac is less than 0 stuff, that is a negative value for the discriminant. In that case, you're going to get two non-real solutions. These are going to be complex conjugates. Okay? So over here, the result after you had worked through this would be x is equal to 3 plus or minus I times the square root of 31 all over 4. You see the complex conjugates, right? Okay? Here, b squared minus 4ac equals 0. They say we get one real solution. Another way to consider that is for degree 2 quadratic equations, we're going to be getting two solutions, but we're going to be getting two real solutions that are equal. Oh, that are equal. Okay, so we only get one unique solution, but actually we get two of them. They're just the same. Like x is equal to 4 and x is equal to 4, or x is equal to negative 3. We got that 2 times actually. Okay, because negative 6 plus the square root of 0 is negative 3. Negative 6 minus the square root of 0 over 2, I forgot to say over 2 on those, is also equal to negative 3. Now, when you have the discriminant, b squared minus 4ac is greater than 0, that means you have some type of positive for your discriminant. And we're going to get two different real numbered solutions, okay, that are not equal. And we saw some examples. There's another one over here in the box. So backing up just a little bit to look at the example, we are going to use the discriminant to determine the number and the type of solutions for each of these equations. Okay, our A value in this equation, this is already organized for us, is going to be 5. The B value is -2, and the C value is +4. So when we calculate the discriminant, which is B squared minus 4AC, this is going to look like -2 squared minus 4 times 5 times the C value is +4. That's going to give us 4 minus 20 times 4. 4 times 5 is 20. 20 times 4 is 80. So the value of the discriminant is -76. Okay, that's not the solutions to this equation, but we do know, since we did get a negative discriminant, if we would go through the process of finding the solutions, we would get 2 non-real solutions. Okay? On number 102, first of all, we need to clean this up a little bit. So we'll have 2x squared on the left-hand side minus 4x. Bring down the x plus 3 on the right-hand side. Now we're going to subtract x from both sides and also subtract 3. I'm going to squeeze that in right there. So our equation now is 2x squared minus 5x minus 3 equals 0. Now that we've got this organized, we can, I'm trying to get this screened in here. We can assign the A value of 2, the B value is -5, the C value is -3. And so when we just do the discriminant, which is just the value of B squared minus 4AC, for the B squared, we're going to be taking -5 and squaring that. That's +25 minus 4 times the A value of 2 times the C value of -3. So here we get 25. Now be careful here. You've got a negative and a negative. We're going to end up adding that because -4 times 2 is -8. -8 times -3 is the +24. So the value of this discriminant is 49. 25 plus 24 is 49. So that means we're going to be getting 2 real solutions. And I would go ahead and say 2 unequal real solutions.